Buongiorno da Roma. Today here at the Iccrom lab, we're going to learn about mortar and we're going to perform a gravimetric analysis of a mortar sample by acid digestion. The objective of this lab is to determine the composition of a mortar sample. This method includes digesting your sample in an acid solution with truly an effort to separate your sand from the binder. So, what information we will be able to learn from this test? Aggregate characteristic, type, grain distribution, color, shape, appearance. We will be able to determine if our sample contains any additives, for example, pigments, fiber, pozzolans. And we will also be able to determine an approximately weight and ratio of our binder and sand. For the binder, we will be able to calculate the materials that dissolved during the acid digestion. But remember, this is important. For a proper binder identification, you need to use different techniques. For example, analytical techniques like X-ray diffraction, spectroscopy, atomic absorption, and also other imaging techniques, for example, petrography. Before we start performing the test, let's just quickly review the main ingredients that make up a traditional mortar. Mortar is composed of an aggregate and a binder that combine together with water form a plastic mass. For the binder, there are two common types. We have the non-hydraulic binder, which set through the loss of water or dehydration, and historically lime is one of the most common one. And then we have hydraulic binder, which set and react with water. Historically, we have gypsum, we have hydraulic lime, we have natural cement, and indeed Portland cement. For the aggregate in mortar, natural sand is one of the most common one. Typically a coarse sand or a carbonate sand. In mortar, the role of aggregate is really to control shrinkage. Remember, selecting an appropriate mortar, whether it's for repointing or rebuilding in your historic structure, it's very important. Because an inappropriate selection can lead to the failure of your repair, but more important, to damage the historic fabric and the historic masonry. So today, let's really learn how to perform this test that will help you in the field to properly design and create a replica to match your historic mortar. Let's really get to work. We're now ready to perform our gravimetric analysis of a mortar by acid digestion. Before we start performing the test, let's take a closer look at all the ingredients and tools that we need for the test. First and most important is your sample. Sample should be representative and of an adequate size. If you're working with a fine grain mortar, you should be using at least 35 grams. And if you're working with a coarse grain mortar, you should be using at least 60 grams. Let's now take a look. You're gonna need your reagent, a solution of 14% of hydrochloric acid of approximate quantity of 250 milliliters. You're gonna need your deionized water. Once you start working with your sample, you're gonna need a mortar and pestle to powder your sample. You're gonna need a glass beakers, glass rods. Then for your filtration, you're going to need a funnel stand, a glass funnel and a flask, and filter paper. For your sieving, you're gonna need a standard sieve set with petri dish. And don't forget, you're also gonna need an oven and a desiccator, a sensitive balance, and a stereo microscope with the Mansell soil chart. And don't forget to wear gloves. Let's get to work. The first step is to complete a visual examination of your mortar sample. Look at the composition, the color, the texture, the hardness. Look at any layering which might indicate multiple repointing campaigns. Look at inclusions of the aggregate at the porosity of the mortar. And make sure to record all your observations. After completing your visual examination of your mortar sample, it's time to powder it. Make sure you weigh it and you have a representative size of your sample, and then you can start crushing it by using a clean ceramic mortar and pestle. After you complete the powdering of your sample, place it in the oven to dry for 24 hours. Here we are again. We just remove our sample from the oven and let it cool in the desiccator for a short amount of time. It's now finally time to weigh our sample. Remember, this is very important. You're going to need to weigh your container and then your container plus your sample, which will become your M1. Let's go to the balance now. After you weigh your sample, before proceeding with the acid digestion, make sure to moisten and dampen your mortar sample with just a small quantity of water. We're now going to start our second phase of the test, which includes the acid digestion, that allows us to dissolve our binder. Start by just adding few drops by using a plastic pipette to record the reaction with your mortar. While we wait for the acid digestion to be completed, we're going to start getting set up for the next step of the test, the filtration. For the filtration, you're going to need a glass funnel, your folded filter paper, a glass flask, funnel stand, and indeed the ionized water. It is very important that you carefully prepare your filter paper. You need to label the filter paper with your sample name using either a pencil or a pigment pen only, and also record the weight of the filter paper dry. When ready, start folding it in 4 and then gently place it inside your glass funnel. Right before you want to start the filtration, make sure that you gently pre-wet your filter paper to reduce surface tension. Now, we're ready with our setup for the filtration and we're gonna get started. The first step before we proceed that you need to do to verify is to add few drops of hydrochloric acid into your solution to make sure that the acid digestion is completed. So what you're gonna do, you're gonna use your plastic pipette that we have from before, and you're just gonna add a few drops into the solution. There is no further reaction, we're ready to start with the filtration. For the filtration, your setup is what we previously prepared and described. Remember, moist and dampen your filter paper to make sure that it tears or it can break, and more importantly, to reduce the surface tension. When ready, you're gonna start adding slowly some deionized water to wash your sample. Make sure to wash to your side of the beaker, and also make sure that if you're using your stirring rod to also wash the rod. When ready, you're going to very slowly, piano, carefully pour your sample into the funnel. Make sure to not break or tear the filter paper, and very important, make sure that no heavier particles are going to fall into your funnel. Remember, the idea is that your filter paper will collect your fine particles. You're going to repeat these steps to add a little bit of the ionized water until you see that the water in your beaker is fully clear. We know that our filtration is completed when we see clear water inside our beaker. It's now time to transfer our aggregate in the oven to dry for 24 hours. You're also going to gently remove your filter paper, place it in a petri dish, and also put it in the oven for 24 hours to dry. "24 hours have passed and we have removed our sample from the oven. Now it's time to record the weight of the filter paper that contains your fine particles and the weight of the dry aggregate. Before proceeding with the sieving of the dry aggregate to determine the grain distribution, make sure to do some visual examination of your dry aggregate. Record the shape of the aggregate, record the color, and make observations. Ready to dance?
Shake, shake, shake. Shake, shake, shake. Shake your booty. Shake your booty.
We have now completed our test. This lab exercise is relatively simple and inexpensive, wouldn't you agree? It provides us with some good information, in particular if you're trying to prepare a replica to match an historic mortar. Let's now just quickly review all the steps that you need to take when performing this test. First, prepare your sample. Complete a proper visual examination, crush and powder your sample, and dry it in the oven. Remember to weigh your sample. Then you will proceed with the acid digestion, where we're trying to separate the sand from the binder and indeed dissolve the binder. And then we will proceed with the filtration, where we will try to separate the fines from the heavier particles. And then we will continue with our sieving analysis that will provide us our grain distribution of our samples. And indeed, in the end, some final examination. This test can be particularly useful if you're working with a large population of samples that you believe to be of similar composition. You can quickly gain information on the aggregate type, grading distribution, color, appearance, and also will quickly allow you to make comparison between different samples. But also remember to be very careful, because this test can be misleading sometimes, as certain part of your sample might be dissolving during the acid digestion, which might lead you to misinterpretation. So, although a very good start, it is recommended that you accompany this test with other techniques. And indeed, remember to do a proper historical research and proper documentation of your building. For now, this is it from Rome. Hope you have enjoyed this episode and stay tuned for more. Ciao!